So if you're year 13 doing A-level maths, you probably have started some year 13 integration at the moment. So I'm going to do a series of videos where I'm going to show you how to integrate algebraic fractions. So in this video one, I'm going to show you how to integrate something that looks like this. Something where you have a constant on the top and you have some kind of linear algebraic expression there and you're integrating with respect to x. So if you wanted to, you could write it like this, a constant over a linear expression. So to deal with integrals like this, the result is this. So what you want to do, you've got this constant a, that constant a needs to remain there because that's just a constant multiplier. What you're then going to do, you're going to write down ln, and then you're going to write down modulus signs like this. And then the denominator of this algebraic fraction goes inside the modulus signs, so ax plus b. And then what you need to do is you need to differentiate the inside of the modulus signs. So differentiate with respect to x. So you divide that by a, because when you differentiate ax plus b, you get a. And now because we don't have any limits on this integration, we just have to add the constant at the end there. So as a final result, you get something like this. Now, why does this work? This is the reverse of the chain rule of differentiation. So if you were to differentiate this thing here, so remember the chain rule differentiation, you differentiate the ln, so that gives you 1 over the function inside the ln, and then you multiply by the derivative of that function, so that u function inside the ln, so that then cancels out the a there, and then you get back to the original thing there. So it's just a reversal of the chain rule. So as long as you know this rule, you can answer any question that looks like that. Example 1, integrating 3 over x, something like that. Well, just using this rule, it's going to be 3 ln modulus of x plus c. Another one, integrating something like this. This is going to be 7 and then ln modulus of 1 minus 2x. But we've got to divide by this minus 2 because when we differentiate 1 minus 2x, we get minus 2. So divide by minus 2. Sorry, my handwriting's gone a bit weird there. So we get minus 7 over 2 and then ln. And that 2's gone horrible as well. Ln 1 minus 2x plus c. Obviously, you could get a question like this where you have to subtract or add algebraic fractions. So again, you just split this into 2 separate integrals. You get something like this, and then we can apply the rules for both integrals. So you got 2, put the 2 there, and then ln of the denominator 3 minus 4x. We want to divide by the derivative, which is minus 4. So just put like an over minus 4 there. And then put a minus sign here, and then again differentiate this thing there. We've got constant 1 at the front, so then we've got ln modulus of 2x plus 1, divide by the derivative of 2x plus 1 to divide by 2, obviously plus a c because we don't have any limits with this question, and then you can just tidy this up and simplify. I'll try and do this over here. So you get minus a half ln 3 minus 4x, you've got minus a half again ln 2x plus 1 plus c. You can actually, because these constants at the front of the ln's are the same value, you can actually simplify and combine the log into one log using your rules of logarithms. I know this is a bit of a mess here, but you can factorize out the negative a half, so then you get something like this inside the brackets. And you know that when you add logarithms together, your rules of logs, you multiply the inside. So what you can do now is write the answer something like this. So something like this, minus a half, multiply the 2 insides, and then you get something like that. Now for tomorrow's integration video, we're going to look at integrating something like this, where you have like a linear expression on the top, but you also have a linear expression on the bottom too. We're going to look at that tomorrow. And also, if any of you are interested in working with me one-to-one on my tuition program, just go to my bio, click the link, book in a call, let's have a chat, and then we can discuss if we are the right fit for each other. So do that as well if you are potentially interested.